Now let's solve this problem. Okay, they have given the table, and in the table they have given the process number, which means our process ID, arrival time, and they have given the turnaround time consists of burst time followed by IO time followed by burst time. Okay, now we need to use the SRTF scheduling algorithm, and then we need to find out the CPU efficiency percentage. Okay, so let's first draw the Gantt chart as usual. Okay, fine. Now at time unit 0, two processes has arrived to the RAM, right? Process P1 and process P2, both are present inside the RAM. Now among these two, we might have to see the burst time. Okay, see, 3 plus 2 equal to 5, 2 plus 1 equal to 3. Okay, now out of 5 and 3, the smallest number is 3, and so process P2 will be having the highest priority. Okay, see, P3 and P4 has not arrived to the RAM. Okay, as of now we have only P1 and P2 time unit 0, out of which P2 is the highest priority. So we will start with process P2. Fine. P2 will continue at least till time unit 2. Okay, because at time unit 2 some new process is arriving. Fine. Anyway, after executing for 2 time units P2, it needs 4 units of IO. Okay, without completing IO, it cannot go for burst, which means it cannot go for execution. So it will start its IO time unit 2 and it will perform IO for 4 time units. So its IO will be completed at time unit 6. Okay, just for remembering, I am writing it here. Okay, process P2 has completed its execution and then it is starting its IO time unit 2 and it will complete its IO time unit 6. Okay, fine. Now at time unit 2, see, as of now, we have already seen that in case if a process is in IO state, see, let us assume these are the processes which are present, right? P1, P2, P3, P4. These are the processes which are in ready state. Okay, which means among these processes, one of the processes will be selected by our scheduling algorithm and it will be given to the CPU. Now, in case if one of the process goes to the IO state, this process will not be available for selection by the scheduling algorithm. Okay, see, if P3 is in IO state, it means that P3 will be removed from this group and it will be placed in some other group P3. Okay, this includes all the processes which are in the ready state. This includes all the processes which are in the IO state. Okay, so our scheduling algorithm will only consider these processes and will select one of the processes for execution, right? It will not consider this process because it is in IO state. See, these processes are in ready state, these processes are in IO state. Anyway, both are present inside the RAM. Okay, just for distinction, I am showing into two groups. Okay, just to say that if a process is in IO state, it cannot be or it will not be scheduled by the scheduler. Okay, it cannot be done by the scheduler because it will not even consider. That's why we have said that IO state is also called as blocked state. Okay, because the process will be blocked. Okay, fine. See, in case if the process is not blocked, what will happen? Our scheduler will again, there is a chance for our scheduler to select P3, right? Now, in case if P3 is selected, it actually wastes the CPU time. Why? Because P3 cannot proceed because it needs to perform IO at this point of time. Okay. See, as of now, I'm not considering that table. I'm just saying for an example that in case if P3 has gone to the IO state, it will be blocked. Okay. It will not be kept into consideration for scheduling by the scheduling algorithm. Fine. Now at time unit 2, process P2 has started its IO. Fine. It will complete its IO at time unit 6. Fine. So as of now, P2 is blocked. Okay. P4 is not available. Fine. As of now, we have only P1 and P3 inside our ready state. Okay. Out of which process is the highest priority? P1's total burst time is 5, P3's total burst time is 3, so P3 has the highest priority, right? See, one more important point, P2 has done this, okay, which means it has completed its first burst and it has become 0, fine. So now P3 needs 3 time units, P1 needs 5 time units, so P3 has the highest priority, okay. So P3 will be scheduled and it will run at least till 5, okay. Why it runs till 5? Because at time 5 some new process is arriving to the RAM. So we might have to check whether this process is having a higher priority or not. Okay, that's why we are running initially till time unit 5. Fine. Now at time unit 5, see, it has completed 3 time units, right? P3 has completed actually there is a actually process P3 needs only one time unit, right? I'm sorry for this actually. P3 can run only till 3, okay? It cannot run more than this because it can run for only one time unit and it might have to go to IO, okay? And this IO will again complete at time unit 6. Why? Because it needs to undergo 3 time units starting from 3. 3 plus 3 is nothing but 6. So it will be completing its IO at time unit 6, okay? Process P3. Fine. Now what time? So P2 is blocked, P3 is also blocked. As of now, we have only process P1. Okay, we don't have P4. Why? Because P4 will arrive only at time unit 5. We are at time unit 3. So there is only one chance, and so we might have to schedule process P1, and P1 will execute at least till time unit 5. Okay, if it executes till for time unit 5, this 3 will become 1. Okay. Now let's check at time unit 5 which are the processes we have. At time unit 5 we have P1 and P4. Okay, out of P1 and P4 which one has the highest priority? It needs to execute for 1 plus 2 equal to 3 time units. Again process P4 might have to execute for 2 plus 1 equal to 3 time units. Okay, so both P1 and P4 has the same burst time. So what we will be doing, so let us assume in question they have given that if two processes have the same burst time, give highest priority to process which has arrived initially to the RAM. Okay, let us assume it was given in the question. Okay, why am I saying this? Because process P4 might have to execute for 3 time units, process P1 might have to execute for again 3 time units. Now out of these two, the tiebreaker is nothing but the arrival time. By going by arrival time, process P1 has arrived first. Okay, so we will start with process P1 and let us assume P1 has completed till 6 and it has started its IO. This has become 0. Okay, and it has started its IO and its IO will complete at time unit 8. Okay, fine. So as of now at time unit 6, P2 is ready. Okay, it has completed its IO. P3 is also ready, it has completed its IO, but process P1 has went into IO state, which means it has been blocked. Okay, now the scheduler has 3 possibilities. Okay, 3 chances, three possibilities, which means it can either schedule P2 or P3 or P4. It might have to select based on SRTF. Fine. Now among P2, P3 and P4, which has the highest priority? P2 needs to execute for only one time unit, P3 needs to execute for 2 time unit, P4 might have to execute for 3 time unit. So definitely it will actually select process P2. Okay, it will select process P2. Yes, it will select process P2. See, P2's execution is done, its IO is done, and it has only one time unit, and so it will complete its execution. Okay, so P2 has been completely done. Okay, we need not consider it because it has went into the completion state, and so all the details about process P2 will be completely removed from the RAM. Sorry, okay, it's very much sweating, so I am actually wiping my hands. Fine, head, fine. Now let's see this. So at time unit 7, process P2 has completed its execution. Fine. And as of now, process P1 is in IO state. Fine. So we have only processes P3 and P4. We need to select one of them. Which one should we select? P3 needs to execute for 2 time units, P4 needs to execute for 3 time units, so we might have to select process P3. Okay, we might have to select process P3 and then it will complete its execution at time unit 9. Okay, so P3 is also done. See, P3 has completed its initial burst plus it has completed its IO as well. Okay, why? Because P3 has started its IO time unit 3 and it has completed time unit 6. Okay, fine. Now it has completed its final burst as well here. Okay, so fine. P2 is done, P3 is done. P4 has now come to the ready state. It has completed its IO. Okay, so as of now we have P1 and P4. Out of these two, we might have to select only one process based on SRTF. Okay, so P1 needs to execute for 2 time units. Yes, P1 needs to execute for 2 time units. P4 might have to execute for 3 time units. Now which one should we select? We need to select process P1. Okay, we need to select process P1. Okay, and then P1 will complete its execution at time unit 11. Okay, fine. So P1's execution is also completely done. As of now, we have only process P4, and keep one point in mind that P4 has never got a chance from the CPU. Okay, which means P4 needs to perform its initial burst, plus it needs to perform its IO, plus it needs to also perform this in a final burst. Okay, so how this will happen is, as of now, we don't have any other process. Okay, only process which is in the ready state is process P4, and P4 will start with its initial burst. Okay, it will continue till time unit 3. It will continue for 2 time units. Fine. After this, it will go for 2 time units of IO, and it will complete its IO time unit 15. So from 13 to 15, see, this is in blocked state. All this has been removed from the RAM because they have reached the completion state. So as of now, no process is in the ready state, and so our CPU will be idle until time unit 15. Okay, because it doesn't have any other process to execute, right? Our scheduling algorithm cannot select any process. Fine. So from 13 to 15, our CPU is idle. Once this is done, this has moved to the ready state from IO state. Fine. Now it will perform this 1 time unit, and so it will continue till 16. Okay, done, completely done. Okay, so what is the CPU efficiency percentage? Our schedule length is 16. Okay, we have started at 0 and we have went on till 16, out of which how much time the CPU is busy? The CPU is busy except 2 time units. Okay, which means our CPU is idle for 2 time units. So 14 by 16 is the CPU efficiency, and in order to calculate the percentage, we might have to multiply by 100 so that we will get the CPU percentage in the CPU efficiency in terms of percentage. Okay, so this is the answer. CPU efficiency percentage is 14 by 16 into 100 percentage. Okay, fine.